Welcome, real-time enthusiasts of SIGGRAPH. Will you please welcome to the stage your MC for the evening, the indomitable, the indefatigable, Cristobal Chang.
Good evening. Welcome to ACM SIGGRAPH's 2017 Real-Time Live Show. To our returning attendees, you know how this works. We'll get to the content as soon as possible. To our new attendees, or if you're new to real-time, you are all in for a treat. All 10 presentations tonight will demonstrate amazing technology, rendering beautiful graphics, and interactively controlling them in real-time live. Like I said, real time, nothing pre-rendered, nothing pre-recorded. So how did we do it? A virtual jury composed of industry professionals with knowledge of real-time technology would evaluate every entry submitted to the program. Their assessment allowed me to make a well-informed decision for tonight's lineup. In years past, the jury has also selected the best in show by awarding one submission the best real-time graphics and interactivity recognition. But this year we got so much great content that we decided to add another criteria, and that is the overall execution of the presentation live. While organizing an event with live demonstrations, my team and I thought, why not have a live jury? Please meet our on-site jury who are here today. House lights? Guys, can you please stand up? They are real. They are here. They will be using various criteria to evaluate tonight's presentations, such as, does the technology represent the best of the real-time field? Are the graphics interactively controlled? Are they in fact rendering in real time? Thank you, jurors. This year's Real-Time Live received a lot of support from our sponsors and donors. We wish to thank Nordeus for sponsoring tonight's show. Their generous sponsorship greatly helps us to organize this event and bring tonight's amazing content to the SIGGRAPH community. We also wish to thank our donors for supplying us with the hardware for tonight. Intel for their workstations, and NVIDIA for their top-of-the-line graphics cards. Both have a booth in the exhibition floor, so make sure to check them out. All right, how about we see something fun? Let me introduce our first contributor. Presenting Limitless VR Creative Environment, please welcome John Collins and Tom Sanaki. John is the creative director at Limitless. Previously, he spent 14 years animating at Pixar, Blizzard, Blue Sky, ILM, and supervised animation for conversation-driven entertainment at Toy Talk. Tom is the CEO and founder of Limitless. Previously, 11 years character lead at Pixar and 4 years character cinematics lead at Bungie.
Hello, SIGGRAPH. We have just a few minutes today, so we're going to build an interactive VR experience from start to finish. I'm Tom Sanaki. This is John Collins. Let's get going.
All right, so as you can see, welcome to the VR creative environment. We're currently in first-person mode, which is great for experiencing content, but for building content, it's much more productive to be in dollhouse mode, which is kind of this authoring mode. You can see that we can move around the scene, and let's go ahead and build a quick interactive scene that offers our audience two different ways for the story to unfold.
So John's put down an interaction object, which triggers a performance when the user touches it. And here he's creating a motion path that controls where the character goes. He's placing some animation clips, and the character will trigger those animations when it hits that point on the curve.
If we want to record a little bit of scratch dialogue to add more depth to our character's performance, we can do so quickly and easily. No.
So John's recorded audio from the Vive headset, and he's storing it on the cloud. John's now creating an action cue, multiple actions that trigger when the character hits that point on the curve. He's placed a fade-out node, and he's taken the audio clip that he just recorded and placed on the action cue as well.
All right, so if we want to do a performance choice that doesn't currently work with our set, say have the Reaper come around to this far side of the bed, instead of leaving VR and going back to the engine to make that adjustment, it's much easier to just kind of do that on the fly. You'll notice a subtle snapping behavior just to keep our set pieces relatively oriented to the ground plane.
John's going to take a second interaction object, place it on the doorknob, so when the user touches that, they'll make a different choice. And now John's creating the performance for that second choice. The speed that he draws out that motion path is the speed the character moves along it. You can see he's placing animation clips on it and will now create another action cue. This action cue he's placing a teleport node in it, which is going to move the user to a different environment when they make that choice.
All right, so let's go ahead and experience what we've built. On this first playthrough, let's assume the audience is going to kind of go along with what the Reaper's asking us to do, which is take the patient's life by touching their hand. Once we do so, we realize, oh, maybe that wasn't the right decision to make, and our scene ends. On the second playthrough, let's assume that the audience instead decides, you know what, I don't really feel like killing this poor person today, not going to happen. They go for the door handle instead, and we have an alternate ending that plays out in which the Reaper acknowledges our compassionate decision.
So now we're in a new environment. This environment was custom built for this real-time live presentation by our friends at Oculus Medium. It was sculpted by Rav Mevlin in Oculus Medium, sculpted in VR, and imported into the VR creative environment. The ease of building content in VR not only makes it fast and easy, but it lets us try out ideas in VR to find out what works best in VR.
You'll notice we have a character here who has a little bit of a different feel. It's a little bit more painterly, a little more 2D. This character was created in Oculus Quill. In just a couple of hours, our artist was able to create a 3D asset for us to then quickly import into the creative environment. Sorry, give me a second. My headset just went out for hopefully a brief second. All right, and we're back. All right, so now let's go ahead and animate our little character here.
So John is reaching out and grabbing joints directly using motion controllers. There's no mouse, there's no keyboard. It's natural intuitive because we already know how to do it. We've done this by playing with dolls and action figures back when we were kids. We're taking the computer out, moving the computer out of the way. And we're finding people are learning this much quicker. They're learning it in minutes, not months. And they don't have to be computer graphics professionals. All of our UX is VR native UX. No menus or dialogues. You just reach out and you touch it. You can see that we put commands and buttons on the arms, and we make those natural and intuitive, like erasers for deleting objects. You can see here John is creating poses, he's setting keyframes, he's moving keyframes around. He could rotate the character to get a different view. He could lean in to see a detail or step back to see it in full context. And you really have to try it yourself. It's even more amazing in the headset. All of the animation you see in this real-time live presentation was built in this VR animation system. All of the content is also stored on the cloud, just like the rest of the VR creative environment, making it easy to share and collaborate. File management is handled automatically. And because everything's integrated, it's easy to try out a new idea. You can record some dialogue, set up some interactions, move the set around, tweak some lighting, create animation, all without leaving the headset. In VR Village, you'll find Reaping Rewards, an interactive VR experience that was prototyped in the VR creative environment. So it's just been a few minutes, but John's almost done with his animation. Well, why don't we cheer him along while he does the last few bits?
Thanks, guys. I will say, as having been an animator for the last 15 years, it's kind of a dream come true to actually see a character in virtual space in front of you and be able to interact with that character directly. It's also incredibly fast and intuitive to animate when the character's right there in front of you, as opposed to having that barrier of a mouse and a keyboard kind of separating you from the world that the character inhabits.
Yeah. So we can all wave goodbye. We're very excited to see what people will do with in VR content creation tools to be able to create innovative VR experiences and speed up 3D content production for film, TV, and video games. Thank you very much.
Thanks.
Thank you, guys. Our second presentation is real-time large-scale water simulation. Please welcome Stefan Jeschke.
Hello.
Stefan got his diploma in 2001 and his PhD in 2005 from the University of Rostock in Germany. Afterwards, he spent several years as a postdoc researcher at the University of Technology in Vienna, the Arizona State University in Phoenix, and at IST Austria in Klosterneuburg. Since October 2016, he is a researcher in the GameWorks team at NVIDIA. His research interests include computer animation, especially water simulation, 2D vector graphics, and real-time rendering. Stefan?
Thanks for the introduction. Hello, everybody. It's really nice to be here. And today I want to present a little wave simulation in real time. Basically, what you see here is a scene of 4K by 4 kilometers. And so basically, this kind of scenes are maybe interesting for computer games, you know, VR, or maybe even movies. And you see that you get a really detailed ocean here. So for reference, I have included this little lighthouse here. And let me see what we can do with this wave simulator that I worked on for the last couple of months. So let me bump up the waves a little. So you see lots of details. So for example, we can add wind waves. So by just tilting the waves in a certain direction here, so they all move to one direction. Or I can also add some like boundary waves, so waves that reflect off the boundaries of these islands here. Let me toggle this a little bit. So now they are off. Now they are on again. So this is pretty nice, and you have probably seen that in other wave simulators too, but we can do a lot more. So let me pick up this little brush here, and just now I can locally attenuate the waves in a certain location. So here you see still we get all the details. It's basically unlimited detail here, and yeah, I can really just draw the waves how I want them. I can even do more interesting stuff. For example, I can do this in a directional manner. So here, I just drew this little, like a swirl, basically. So you see, there are not really artifacts, but I mean, it's a quasi-static simulation. So it looks a bit weird because in nature you would hardly see something like that. But you can imagine in the hands of a designer, this tool could make some really good news. Models or some nice effects, basically. So let me draw something else here. So actually, I'm not a designer, but a few maybe interesting things I can still show with this. So here you see something like an underwater volcano where the water seems to like boil at a certain location. Or I have another example that might be more practical oriented. So you see this gap between the islands. And now I can just quickly sketch the waves in a way that they appear as being like a channel flow through these two islands here. So let me talk a little bit about how the whole thing works. So what's under the hood? Basically, we work with a grid of this grid cell size. That's basically a 1 meter grid. So each grid cell has 1 meter side length, and you see that the waves are a lot finer than that. So basically what we do with the grid is whenever I paint something, I visualize here what I paint, and that you can intuitively understand as something like directional wave energy. Right? Where the color encodes the direction. So for the swirl, I get this nice color wheel here, and the brightness indicates the overall wave energy. Right? But we can do even better. So let me add a few dynamic objects in this simulation here. That takes some time. Here we go. So now I added a few boats, and you see that the boats now, they act precisely as the brushes, but at the same time, the colors that they brush on this grid, they get advected. So we use some simple Eulerian simulator for that works on this coarse grid. So of course, we also want to see how this looks in the visualization or in the final visualization. So here you see that each boat emits just a nice wake, right? And if you look at it, basically I added here 1,000 boats to the scene. So you see that there's a lot going on here. So it's still this 4K by 4K scene, 1,000 boats, all animated here at comfortably like 45 frames per second on a GTX 1080 in this case. So that's really nice. What's more, the wakes also, they reflect off boundaries, and lots of nice stuff is happening here. So, and still, you get all the details that you want. So you can really go close to this. And you can also jump around in the scene. There's no adaptive data structure or whatsoever. So it's really all what you see that actually happens. But this is not just something that you can look at. You can also play a little bit with it. So here I added a little jet ski simulator where the jet ski can jump over some wakes from the boats, for example. Something like that. Right? Or what you can also do is, let me clear up the waves. You can also throw a box in here. And you see that it creates some sort of a wake, but here we really drove the simulation to its maximum. So you see that the box size is actually the same as the grid size. So you cannot go much smaller with your objects you're going to animate than this. But you can throw in some more boxes like this, and they all create their own ripples, and they also bounce a little bit and get dragged away from the wakes and from the waves. Or you can also go a little more crazy with this and just emit 1,000 boxes. So it's kind of cloudy with a chance of boxes, if you will. And all this is still happening. So now we see 1,000 boxes, 1,000 boats, all in a big scene with more or less unlimited details. And all this is happening at real time. So let me again do a box rain because it was so awesome. Okay, so I think, or I hope you got as excited as we got over this. And thanks for your attention.
Thank you, Stefan. Our next contributor will be presenting Star Wars Battlefront VR, piloting an X-Wing for the first time. Please welcome from Criterion Games, Matthew Patterson, Christian Benz, and Angel Munoz. Matt specializes in rendering and systems. Chris works as an environment artist, and Angel specializes in rendering. Their work includes games like Battlefield, Need for Speed, FIFA, and Battlefront, as well as more general features for the Frostbite engine. VR Jedis, may the Force be with you.
Thanks, Chris. That's awesome. Hey, everyone. I can't see you, but hopefully you can see the screen and everything's working OK. So we're from EA Criterion, and we're here to show you the work we've done on the Battlefront X-Wing VR mission. So as you can hopefully see, we can look around, say hi to our R2 unit over there. Maybe let's see what this button does. Oh, gadgets. I like toys. Oh, let's not crash into this. There we go. So because we're using the auxiliary output port of the PSVR, unfortunately what you're seeing on the screen is slightly lower resolution than what I'm seeing in the headset, but hopefully it'll still hold up OK. We'll be switching between this mode and another mode during the presentation, so we can show you a bit more debug information.
Yeah, but before we go into that mode, let's talk about the biggest battle that we had in this game, which was performance. So we had to maintain 60 frames per second all the time, so that when PS4 reprojects that to 120 Hz, the prediction that we are using is correct, and that way we can reduce motion sickness. So we had to implement some optimizations in Frostbite in order to achieve this. If we go into separate mode, hopefully you can notice the first one. So the pixels around the corners are missing, and that's because when we apply the distortion to show this image on the lens of the headset, those pixels are going to be lost. So first thing we did is not waste resources processing them. Another thing that happens due to this distortion is that the pixels around the center area of your vision gets magnified. And what that means to us is that we had to render at a much higher resolution. So we're rendering at 1.4 times the native resolution of the headset. The native resolution is 1080p. And we're also using temporal anti-aliasing. And the reason we're using temporal anti-aliasing and we are not using other kind of anti-aliasing like MSAA is that unlike MSAA, that only removes aliasing coming from geometry, temporal anti-aliasing also removes the aliasing coming from shaders, so texture noise and specular aliasing, which is really important for us as we are using a PVR model. So if we come back to our path.
There we go. Sorry, guys.
There we are. And now we face the sign and pause there. So if we disable temporal anti-aliasing and Chris looks around, hopefully you can notice the aliasing coming from the specular. If you were wearing the headset, you would also see like aliasing coming from geometry and texture. But hopefully you can notice. Let's re-enable it. There you are, nice and smooth. So TA was a massive improvement for us in terms of visual quality. Another thing worth mentioning is probably shadows. So shadows are really important in VR. We're using a traditional cascade system, but we're using one slice just for the cockpit, so that we reduce shadow acne. And we are sure that for the rest, we have a draw distance long enough to cover the entire asteroid field.
So another decision we had to make was whether we use deferred or forward shading, and we found in this case that actually forward plus gave us the best performance for the number of lights we're after. So if you can see when Chris fires his lasers, it's affecting the cockpit and the nearby scenery, but also many of the VFX and other ships have lights attached, so we can have end up with a lot of light sources in our scene. Now Frostbite has a lot of cool features in this area, such as area lights and reflections. But unfortunately, we don't have the performance available to actually make use of them. So instead, we're having to fall back to fairly basic options like point lights and cube maps. Also, because we're using Forward Plus, the cost is now in every pixel that we render. So to kind of ameliorate that, we use a pre-Z path to ensure we reject as many pixels as possible. Another Frostbite feature that we rely on heavily is dynamic resolution scaling. So as the complexity of the scene increases and the load on the GPU goes up, we can drop the resolution of the render targets that we use, meaning that we process fewer pixels. So if I just bring up this graph here, the yellow line that you can see on the graph shows the current resolution scale as it varies. There's 1.4 at the top and 1.0 at the bottom. And it's got the resolution at the top right-hand corner, although, yeah, bonus points if you can spot what's wrong with it. What you can see here with the dips is where the GPU would have framed out, but instead of that, we dropped the resolution. If we didn't do that, the player would start to feel uncomfortable and it'd be really horrible. This proved to be a really key technique for us.
So in VR, sorry, I got a bit lost there playing. It's kind of fun. So in VR, heavy shaders and expensive lighting usually has to be rendered twice, so you quickly increase your rendering cost. This is why we put most of our details, more details than usual actually, in the textures and geometry. Wait a minute. Into the geometry and textures instead, which is relatively simple to process for VR. This allowed us to get a much higher quality out of it than we would initially expect, considering the limitations.
So these things that we've mentioned today, plus some other optimizations, meant that we managed to get the X-Wing VR mission to a fairly steady 60 frames a second, and hopefully have managed to keep the visuals of decent quality. Hope you've enjoyed the presentation. This is it's a free DLC for Battlefront, so if you get the chance, please give it a go, and we hope you enjoy it. Thank you for listening.
Ooh, exciting. Thank you, guys. Our next presentation is Superposition Benchmark Innovative SSRTGI Lighting in Real Time. Please welcome Unigen's CEO, Dennis Schergen, and Unigen's lead 3D artist, David Widiger.
Hello, everyone. We are from Unigen, the company behind Unigen Engine.
My name is David Widiger. I'm lead 3D artist.
I'm Dennis Schergen, CEO of the company. Our engine is well known for handling planet-scale visualization projects, but besides that, we our company developed 5 GPU benchmarks based on the same technology.
Recently, we released a new superposition benchmark with VR features and high degree of interactivity.
Пробел.
Sorry, it's real time.
Давай еще раз.
And high degree of interactivity. It also has our unique lighting technology, which we called as SRT-GI. This technology is the focus of our presentation.
What are the problems we are solving here? Unlike regular applications, we have 900 dynamic objects in a single room. All of these objects can be moved freely and affect lighting of each other drastically. This scene unveiled a set of typical problems in modern 3D engines. Most of them use a combination of light maps for static objects with light probes for dynamic objects, and introduces a set of problems with lighting. First, dynamic objects stand out against static ones lit with light maps. Second, if you try to rely on light probes for all the objects, it will give us more consistent look, but there will be problems with ambient lighting. For example, take a look at noticeable edges on adjacent surfaces and ambient light bleeding through objects. And third, close-up shots are still the problem for real-time 3D graphics. And people can notice even slight imperfection in small things because we deal with human-sized objects every day. Why there are not such problems in offline rendering? Well, ray tracing, that's why. But unfortunately, even powerful GPUs can render ray-traced images with only a few frames per second and a lot of visible noise. Luckily, we use ray tracing only for imitation of global illumination, and we combine it with traditional analytic lights in order to achieve really good performance.
Together with Michael Lubimov, our lead rendering engineer, we experimented on further rendering improvements of Engine 2 render. As you know, trendy screen space reflections overlap troubled reflection from environment probes. Just for fun, we decided to use the same algorithm for calculating of global illumination. The result was very impressive, making old renders look non-realistic in comparison. We extended this approach to ambient occlusion, to secondary bounds of diffuse light and self-illumination of objects. And also we implemented bend normals technique for smoothing normals between different surfaces. Surprisingly, it all worked very well. We call this technology screen space ray tracing global illumination, as SRT-GI. Let me explain the details. We use real ray tracing, but only in screen space, taking obstacles into the account. We have 3 adjustable parameters. The number of rays controls noise level. The number of steps controls distance of ray tracing. And step size controls precision of geometry intersection. As a bonus, I can enable emission for the objects to make them illuminating with ray traced light. I can scatter these objects and the lighting still will be consistent. This technology works per pixel for any distance, ranging from close-ups to outdoors.
So what are the results? SRT-GI gave us really consistent and good-looking image. Also, we got rid of long process of baking light maps. SRT-GI has really nice potential because it can be used as a replacement for usual screen space global illumination with comparable performance. And it can go even further in terms of visual quality on higher settings. The performance is really good, as you can see here. It's above 60 FPS and it's 100 FPS right now, with all the other effects on a regular GPU. This technology is already used in production since it is a part of Unigine 2 engine for several months.
Superposition benchmark It's available to anyone. You can download it from our website for free. It works in VR as well. We wish to say special thanks to brilliant implementation of this technology to Michael Lubimov and to the rest of Unigine crew for support. Thank you for your attention.
Thank you, guys. Please give a warm welcome from Pinscreen Inc., Hao Li, Iman Sodagri, Koki Nagano, Jaiwoo Seo, and Kerry Sun. They will be demonstrating Pinscreen creating performance-driven avatar in seconds. Hao Li is the CEO of Pinscreen, professor at USC, and director of the Vision and Graphics Lab at the Institute of Creative Technologies. Iman has a PhD in computer science and is Pinscreen's VP of engineering. Previously, he worked for Google, Disney Animation Studios, and ILM. Koki and Jaiwoo both worked at Weta before and are now lead engineers at Pinscreen. And Kerry recently joined as a software engineer.
Thanks so much. Hi, everyone. So we're Pinscreen, and as we all know, virtual and augmented reality is really driving the graphics industry these days. And as VR is becoming the next generation platform for communication, social VR might change the way we're going to communicate in the future. So if you want to communicate or interact in VR, you have to become a 3D avatar. And 3D avatar or digital characters are notoriously difficult to build. Usually it requires a full-on production pipeline. You need a lot of digital artists or sometimes even complex hardware equipments. But we're going to show you how to make it really easy. So what we're going to show you later is how to build a high-quality 3D avatar from a single image, fully rigged, animatable, and we're going to show you how to bring them to life using a single webcam. So let me pass over to Iman, who's going to show you the first demo.
All right. Thanks, everyone, for coming to our demo at Real Time Live, and thanks for the introductions. At Pinscreen, we've been working on developing a fully automated pipeline to create 3D avatars from a single image in a matter of seconds. And today, I'm going to show you how it works. For that, I'm going to use the webcam here to take a picture of myself. So first, you need to take a selfie and make sure that it looks good. And then you cross your fingers for a few seconds. And there you go. We have the full 3D avatar. Thank you. And we can switch to the mesh view to see the underlying mesh. And we can switch to X-ray mode to see the skeleton and the joints. Our avatars are fully rigged and are ready to be used in VR, games, and animated movies. To create another avatar, you would only need to use a single image. So I have a picture of Hao with a different hair color. I'm going to use that one. And in a few seconds, we'll have his avatar. So once we receive the image, we run multiple neural networks and pixel-wise optimizations to calculate the hairstyle, the geometry of the hair, poly strips, the face geometry, albedo texture map, and the lighting, the eye color, and so on. I'm going to create John Root, one of the judges of Real Time Live. For better performance, we run our neural networks and optimizations on the GPU. And now I downloaded a picture of Cristobal. I'm going to create his avatar to see how he's going to turn out. The image is actually low res, but hopefully the avatar is good. Looking good. So for the appearance, our goal is to be right before the uncanny valley, right in the sweet spot. And for real-time rendering, we use the Unity game engine. So now I'm going to invite Koki to show you how we can animate these avatars in real time using your own facial expressions. Thanks for your attention.
All right, so thank you, Iman. Now let me show you how we can animate these avatars. I have already created my own 3D avatar, so I'm going to use it. As you can see, our tracker is real time, goofy face, no problem, and markerless, and only requires an RGB camera, no depth sensors, or no special hardware. There's no pre-calibration or pre-training to adjust to the driver. And since we have a high-quality rig, we can automatically drive the avatar using just a single webcam input. Now I'm going to switch to the tracker view to show the underlying road geometry being tracked. And this is, as you can see, our tracker is highly robust. Even if it fails, it comes back. And also, it can capture large head rotation. And also exaggerated facial expression. For this, we use a pixel-wise optimization to solve for facial geometry as well as facial textures, as shown here. We also solve for the surrounding illumination, and we can interact with the virtual avatar. Can we dim down the light a little bit if that's available? Okay. Right. So as you can see, we can interact with the virtual light, with the physical light. I'm holding the LED bulb here with the virtual avatar. So I'm going to switch to the avatar view. And I'm changing the direction of the light. It's a very dim light. I think it's very challenging to track, but our tracker still works. And then also, we can change the color of the light. Whoop, it's a little bit difficult. And still works. Everything happening in real time. This way, we can get a true augmented reality experience where the virtual avatar seamlessly blends into the real world. Now, I'm going to pass the demo to Jay and Carrie, and they're going to talk about how this avatar technology can be used in immersive AR chatting scenarios.
Thanks, Koki. So the cool thing about using this tech as opposed to traditional video chatting or face filters is that using avatars allows you a new degree of creativity and fun. So to show this, Jaywin and I have set up a virtual chatting environment to simulate what this would be like. So I can ask things like, hey, Jaywu, how are you doing?
Hi, Carrie. How's your first SIGGRAPH going?
It's actually really good. You know, I never thought I would be speaking at RTL with such a distinguished jury and audience. So to suit this conversation, I can switch to avatars such as John Root or Jerome. So can you show me what you can do?
Sure. Check this out. Let me transform into a friend I like. Yeah. So as you can see, by using our 3D avatar and tracking technology, you can be anyone you want, as long as you have a picture of them. Anything is possible.
Yeah, you look really familiar.
That's right. Yeah. Yeah, check this out as well. Yeah, because we have our avatars in 3D space, we can basically immerse ourselves in a virtual world, and we can use different, different environments and personalities, just like this. Yeah. This is much more than just chatting in face-to-face. So you can use different characters, different animations, and different backgrounds to create much more dramatic chatting experience. Yeah, so I think that's it for our AR chatting demo. How, do you want to say something else?
Yeah, so if you really like what you just saw, we're going to release the technology in product soon. So please visit our website. You can sign up for the demo. And Pinscreen is also expanding, and we're hiring. So send us an email. Thank you very much.
Thank you, everyone. Here to demonstrate Penrose Maestro, please welcome our next presenters from Penrose Studio. We have Devin Penny and Bruna Burford. Devin is the head of engineering at Penrose Studios. Previously, he was a lead engineer of the effects R&D group at DreamWorks Animation. Runa is the head of animation at Penrose. Previously, she worked as an animator at Oculus Story Studio and cinematic artist at Telltale Games.
Great, thanks a lot. All right, hi everyone. My name's Devin Penny. I'm the head of engineering at Penrose Studios. At Penrose, we create VR and AR narrative stories. And today we're going to show you this tool called Maestro that we've developed to review our content in VR. We think that if you're going to be creating content for VR, you should be reviewing it too in VR. And we found that by doing this, we've been able to both increase our quality of our work and the speed at which we create it. So what I'm going to do now is just jump in there and just show you guys. OK. So here I am in the world of Arden's Wake, which is our upcoming short film. And you can see this like really detailed set around me. And everything in here we've reviewed using Maestro. So for instance, I'm just going to point with a laser pointer here. You know, I can like kind of look around. This submarine was reviewed from the modeling stage to the shading, and then also final lighting. And also, you know, we have a lot of character animation, and I'm going to just walk outside. We try to utilize positional tracking whenever we can with our stories. And so I just want to point in the distance. You can see a boat wake coming off that boat. That's a real-time fluid simulation that we developed that also was reviewed with Maestro. And you know, we're also have this underwater world with fish and volumetric rendering, all that really became much better because of the fact that we were reviewing it in VR. So I'm just going to pause this here real quick. So probably the biggest place that we've used this tool is with animation. So in Arden's Wake, we've reviewed about 30 minutes of final animation and really increased the quality as a result. And so right now I have some new animation for our character here, Mina, and I really need some help reviewing it. Luckily I have my head of animation here, Bruna, to come help me out. Hey Bruna, do you think you can help me give me a review?
I think I'm a little bit busy here. Can you call someone from the studio back?
Oh shoot, you know, that's startup life for you. Oh, you know what? I think we have someone. Terry, you're remote, right? Can you come in here and help me out?
Hey, Devin, how's it going?
Oh, hey, how you doing?
So what can I help you with?
Yeah, so, well, first of all, I just wanted to show everyone, like, how we're represented in VR. So you can see Terry is represented both as a head and two hands. You know, he's able to move around and everything. So, Terry, you know, I have some new animation. I'd really like some help reviewing it. Do you think you could, you know, give me some assistance?
And I'm here now.
Oh, yeah. Wait, we have Bruna here, too.
Oh, Bruna.
Hello.
Hey, how's it going?
I'm back. So we use this Maestro pretty much every day on our pipeline. It's fairly simple to use. You can use the buttons and the joystick to move around and navigate in the scene. You can go up and down, and you can also like rotate in place. If you look to your left hand, you can see a menu option where you can play, you can pause, you can rewind 5 seconds, you can go forward 5 seconds, or you can go frame by frame. This is extremely helpful for animation because if I want to review something in VR, like I can keep playing that as many times as I need. The other cool feature about this tool is that I can actually like play and navigate at the same time. So I can actually like see my animation from any angle. So here, for example, I think that this pose is quite not working that well. So if you want to come over this way, you can see where I'm looking. I can actually like draw in VR, so I think this, like, she should just turn around and go this way. I think it will look better. What do you think?
Okay, well, let me just take a look. You know, I don't really get what you're going for with that, unfortunately. You know, luckily we have Terry here who's remote, and he can kind of help out and give us another opinion. Terry, can you tell us a little bit about how the remote works and like what we've used it for, and then, you know, give us some help here?
Yeah, definitely, Devin. So the other great thing about Maestro is it allows us to connect with one another no matter where we are. During our film premiere at Tribeca, we were actually able to still conduct animation reviews, even though half of the team was in San Francisco and the other half of the team was in New York, 2,500 miles away. We've actually been able to have up to 20 people in a review at the same time. So I see this line that you've drawn here, Bruna, but what if Mina just turned around directly and went directly back down the dock?
Oh, interesting. Yeah, I mean, that looks really good. You know, I think with these two things here, I can probably come up with a really good new version of this. Luckily, we have this export drawings option so they can export it to third-party applications to make use of other tools. All right, I'm going to get offline, guys. I'll see you later.
All right, see you guys later.
Bye. OK. So.
It's just a little face.
Oh. Nice. All right, so I'm going to exit out of the experience and minimize our engine here and just load up Maya and just drag the drawings over here. All right, and we can see that it loads up and lines up perfectly with what we drew in VR. And I can go ahead and now start animating a new version of this. And the real advantage here is that we're able to make really good use of third-party tools, and we're also exploring new opportunities for doing asset creation in VR, and that's something we're exploring more and more every day. And if you want to learn more about Maestro, we're going to be doing a talk on Thursday that goes into more depth about new features too. All right, thanks everyone. Bye.
Thank you, guys. From ETH Zurich, please welcome Lubor Laditsky, here to present Physics Forest's real-time fluid simulation using machine learning. Lubor is a senior researcher at ETH Zurich. His current research interests lie primarily in speeding up physics simulation using machine learning. He co-founded a spin-off company, Apagom AG, transferring this line of research into the industry.
Okay, thank you very much. So in this presentation, I'm going to talk about our approach for real-time 3D fluid simulations using machine learning. That means instead of solving those underlying Navier-Stokes equations, we train a regressor which predicts the same thing. That means it predicts the behavior of particles in the constant time-step regime. The simulation can have some additional rigid bodies, like these stones, with which I can change the flow of water. Yep. Or I can, for example, throw stones and I can splash. So you might ask yourself, why exactly would we want to do this? The first advantage, as you might have noticed, is that we can simulate much larger scenes with up to 10 million particles in real time. You can see that now we are in real time on a single GPU. So you can see that we are now reaching almost 7 million particles. You can throw this teddy bear and you can see that the teddy bear interacts with the water and also water interacts with teddy bear. The second advantage is that we can regress together surface together with the behavior of particles, and this gives us more power when it comes to rendering effects like you can see reflections of the teddy bear or the shadow of water or refractions with the shadow there. So third advantage, and probably the most important for real-time applications, is that our method is very stable. That means not only in these standard regimes like this one, you can see how does it behave, but if you give it to a user, typically after 10 seconds he starts to do this. So let's hope it doesn't break. As you can see, the water quickly regained its shape and volume, and simply it didn't really break. That means even though it wasn't probably physically correct, the simulation stays stable because it has never observed diverged simulation during training. It simply fails to extrapolate during test time. Our model is parametric, and that means that we can simulate all kinds of materials which differ in viscosity, like this one, and adhesion, or alternatively surface tension or density. We can also simulate non-Newtonian fluids such as sand. So sand looks sandy. You can see that it's non-Newtonian because the surface doesn't end up being flat if you wait for long enough. And typically the simulation is quite boring for sand, so we can make it a bit more interesting with a little bit of tornado. And you can see that, yeah, trans without really any problems. So we can also render all kinds of other materials. That means the ones which are opaque reflective, like this coffee, or highly reflective, such as mercury. And you can see mercury has higher surface tension and also higher density, and that's why objects float higher on the surface. And if you are interested in seeing exactly how does the particles behave, I can zoom it in, and you can see every single particle in this minced meat or chili sauce or whatever it is simulation. Yeah, so you can see every little detail, so I can, mix it slowly, such that you can see every. Okay, it wasn't that slow. Yeah, so our approach can be straightforwardly generalized to multiple fluids. That means this here, that this sandcastle will be destroyed by this water wave. Okay, let's wait till it gets destroyed. Let's hope it falls. It doesn't always fall. Now it didn't. Okay, so let's help it a bit with the tornado. Okay, I think we succeeded. I can help it with this wheel. Okay, so now it's all destroyed. Okay, so the next feature which we can handle is we can diffuse any kind of property, in this case color, but it could be any other property, for example temperature, and then based on the temperature we can model some whatever property can change depending on the temperature. But here you can mix a bit this paint, and you can speed it up with a few swirls. I think I can make bigger swirls if I do this, because swirls is along the whole axis. So if you wait for long enough, everything ends up being of this grayish, greenish color. Okay, and in this last scene, yeah, we simulate lovely interactive rubber ducks, and yeah, I can splash them. It's lots of fun. I could play with it for hours. I really did. Anyway, so I hope in this talk I managed to convince you that machine learning-based physics simulations have a potential to replace traditional solver for a large, for many tasks, especially the ones where the running time and stability matter more than the physical exactness. Okay, thank you very much for your attention.
Thank you, Lubor. Next up is Direct 3D Stylization Pipelines, presented by Santiago Montes de Oca. Santiago is pursuing his PhD at the Nanyang Technological University in Singapore under the Multi-Platform Game and Innovation Center, MAGIC for short, and is also collaborating with INRIA in France. He has a profound interest in expressive rendering and its usability, enabling new narratives through unique looks. This research is supported by the Interdisciplinary Graduate School, IGS, at the Nanyang Technological University in Singapore, and the National Research Foundation from the Prime Minister's Office in Singapore under its Interactive Digital Media Futures Funding Initiative.
Hello, everyone. My name is Santiago, and I'm coming all the way from Singapore to give you a sneak peek into direct 3D stylization pipelines. Now, the motivation behind this pipeline came from the need as artists to locally be able to art direct a stylized render. Now, normally you would have to render several different passes, put them together in compositing, and then at the end, after some post-processing, see the final result. However, this is a bit disconnecting and non-intuitive for the artist, because any change that needs to be done everything needs to be re-rendered, brought back to compositing, and again post-processed in order to see the change. Now, what if we could do this in real time? What if the artist would be able to do any change they want and have it appear immediately on screen? Now, for my research, I had to create a watercolor stylization of a 3D render. Now, this is a normal render, which after some post-processing passes, such as the pigment density, the color bleeding, the edge darkening, gaps and overlaps to increase some sketchiness, then pigment application, substrate distortion, and paper lighting, all these effects together give this watercolorized result result of this house made by Rafael Scope. Now, as you can see, this is performing all in real time. Now, you might be used to manipulating stylization probably through presets, where you can load some predefined looks to it. And you might also know and have used before probably the use of sliders here. For example, here I can manipulate the amount of the paper influence of the render. Now, the problem is that with these global effects, you cannot create a render like this one. Why is that so? Because there are effects, especially in watercolor and other traditional media, that don't affect the entire image. They only affect, for example, here, the gap is only present in certain areas of the render. As you can see, the same thing with the overlaps and the dry brush. Now, this is where a direct 3D stylization truly shines. Why is that so? Because it is being driven, the entire stylization is being driven by the control target in the background. And this control target is assigned in the object space. Now, the cool thing is the artist doesn't really need to bother about this control buffer, because he can make all the changes on the fly directly in real time. So if we come here and say we want to increase the pigment density on this side of the house, you can see the pigment is being accumulated. Or if we want to increase the granulation, which means the accumulation of pigments only in the valleys of the paper, you can also use this and intuitively paint directly on the object. And as you can see, all the effects stay where you have assigned them. You can do the same thing with other effects in watercolor, like color bleeding, for example. I'm going to reduce the brush size here a little bit, increase the influence, and then I can blend in the colors where I'm actually painting them. And as you can see, this stays where I originally assigned them. Now, you might wonder, how does this look like in motion? So we have this little guy here, made by Bastien Genbrugge. And the cool thing about this is I'm using a lot of gaps and overlaps, in this case, to increase the sketchiness of the overall watercolorization. Now, let's not forget that we're in 3D space, so apart from the stylization, you can keep using things like lights, and of course, continue to art direct it to fit your desired style. For example, here, I have a gap that is a bit too long, so I want to change that. I want to paint an overlap instead. So I make this brush smaller, and I'm changing this gap into an overlap. So now I have two gaps and then a little overlap here. And the same thing you can do with other watercolor effects in this case. So I can come here and say I want to darken the edge on this area of the model. Now, you might not see this right away, but if we flood it a little bit more, then you can see the difference. And the same thing, you can make it as wider as well. And then if you want it to have it narrower only on one side, you can paint the effect on that side of the geometry. So it will stay there. Since we are handling the edge darkening, it will only appear when this part of the geometry is an edge. And the same thing you can do with any other watercolor effect that you have implemented. For example, we can go here and create some dry brush to it. And this is all being handled in object space, all the assignment, and being driven by the control targets that we have here. Now, I see this technology being used for more than just animation and in film or TV. Since this is in real time, we can think about games with this technology, or even VR. And the closer we come to the traditional medium, for example, we have here watercolor, the closer we come to real watercolor, the more we can start thinking about interactive art that is indistinguishable from the traditional counterpart. Now, our implementation is openly available already for everyone to use, and we're planning to open source this direct stylization pipeline within Maya next year. So we want to motivate you guys to adopt different looks to bring some variety overall to the look of 3D graphics nowadays. With that being said, I thank you all for coming. Have a great evening.
Our next presentation is The Human Race. Here to present are Eric Renaud Haud, Joji Suruga, and Michael Gay. Eric is developer at creative technology and VFX studio The Mill. Joji is the real-time supervisor at The Mill. And Michael is director of cinematic production at Epic Games. This project was a collaboration between Epic Games, The Mill, and Chevrolet.
Thank you, Chris. Hello, everyone. So earlier this year, The Mill collaborated with Epic Games and Chevrolet to create a short film called The Human Race. And it was a case study on the impact of real-time technologies on the visual effects and filmmaking industry. And on our project, we had 3 major components. So Eric, if you can walk us through this setup here.
Yeah, certainly. So the first step was the Mill Cyclops, a virtual production toolkit we created in order to assist on-set visualization in any location. In fact, we really put it through its paces when we shot this on the mountain roads of California. So to replicate some of that here today, we brought our Blackbird car rig for a live demo. So for shoots where the main characters or objects are entirely CG, the raw video feed like this is not the most helpful, even with placeholders. Where would the headlights or the driver be exactly in frame here? Lighting and framing can be guesswork. However, with the addition of real-time tracking from Array, we can augment the hero camera feed with a virtual object, like so. And this is already much more useful, but it's still severely lacking in realism. So to push the quality further, we've placed a camera on top of the object we're tracking. It's capturing its surrounding environment and streaming it back to our application in real time as a secondary video feed for image-based lighting. And so if I turn this on, you can see now how the virtual object really does sit much better into the video backplate. So Joji, what do you think of this shot?
It's looking good, but I think we could do a little better. Can we adjust the framing a little bit, please? It's looking cool. Let's stop around there. Cool. So to shape the car, let's add some highlights on the top of the car. Can we, yep. Shift it forward. Cool, nice, nice. So in this way, directors and DPs can light the car, frame their shots, and really visualize their shots while they're on set. So now that we saw how we shot the film, let's take a look at how we crafted the film in Engine. Michael, can we play that clip?
Sure. So actually, this isn't just a clip. What we're seeing is a live composited and rendered view that's happening inside the engine. So the other cool part is that we're using EXR streams. So we have each one of these shots has up to 3 EXR streams for it. And these are full-res, uncompressed EXRs. So we're actually putting about 1.8 gigabytes a second of throughput to the engine to maintain a solid 24 frames a second here.
So there's a shot in here that I'm not happy with. Can we jump into shot 140, please?
Sure. Go back into simulate here. The shot here?
Yep.
Yeah, let's dive in.
So it looks like the lighting's a little off. Can we spin the sunlight around?
Sure. Go up here. And just grab the sun and drag this around a little bit. Something maybe more like that.
Yep, that looks a lot better. Can we try adding some more smoke effects on the tires?
Sure, we could kick that up a notch. Go back down here. We'll just grab the left one. What do you say, like maybe 10 times the amount?
Yeah, let's go for it.
Sounds good. All right, kill this key here. All right.
Cool. And lastly, let's try and add a lens flare to the shot. Can we add a second layer?
Sure. Come down here, and what we're doing is adding another, actually, another EXR stream to the shot, so it should be pretty cool. All right, so now you can see we've got a little lens schmutz there and lens flare.
Nice. So maybe we can take a look at our clip again with our new adjustments.
Sure. Let's check it out.
So as you can see, making a film in Engine comes with huge reward. there's rendering all the CG, bringing in all the live action sequences, and also compositing each frame every 42 milliseconds, which allows us to have a fully interactive film. So if we can take a look at the configurator now, we can see how that customization works. So any Transformers fans out here? Let's Bumblebee.
And if we go into picture-in-picture on the main screen, we should also be able to see that the AR app is being configured.
Let's try a few other colors. Can we try Garnet Red?
Sure.
Or Hyper Blue? So if anybody likes classic cars, let's try swapping the model to the 68.
Now that's great and all, but but Joji, do we have something other than cars?
Let's jump into a safari mode. So these innovations in shooting the film, crafting the film, and interacting with the film is why we believe the future of filmmaking is real time. Thank you.
Thanks.
Wow, that rhinoceros is running faster than it normally should. Before I introduce our last presentation, I would like to once again thank our donors. Intel and NVIDIA, you have seen their hardware in action with some of the demonstrations and how well it handles the stress of real-time rendering. And another big thank you to our sponsor, Nordeus. The donations and sponsorship Real-Time Live received shows how strongly the industry believes in the content we bring every year at the SIGGRAPH conference. Now, our last presentation is an invited piece to Real-Time Live. Please give a warm welcome from Unity Technologies, Amir Ebrahimi, Matt Schoen, Dylan Orchidi. The Unity Labs Editor VR team is developing new ways to create and experience digital content across mediums. Amir was the chief architect. Schoen and Dylan are senior engineers on the team.
Thanks, Cristobal. Great. So what we have here is SteamVR's SDK. We've stripped down everything except the longbow and one of the Weeble objects they give you. Now, if we were to build a quick game out of that, we would write our own little script, which we have here, which allows you to sequence these in order. And if we were building these normally in Unity, we would link them together. So, for instance, if I had this one selected first, and I wanted to go to that one next, I would drag that over and drop it on that field right there. And then I would put my headset on and go into play mode. Then let's say, something in our game isn't right, like maybe that's too far away. If I were building this traditionally, I would take the headset off and then go make an adjustment there. But wouldn't it be much easier if we could just do that in VR? And Sean's going to show you that.
All right, well, thanks, Amir. So first off, this is Editor VR. You can see that I have the VR view showing up on top of Unity, and that's showing you what I can see in the headset. So the first thing that I want to show you is that we got our scene here with the two Weeble targets, the bow, and kind of a more fleshed out scene, close to what you might see in, later on in development. And I've locked down everything around this interaction scene so that I can't interact with it, but I can interact with all the trees and stuff around me. So let's just get our bearings and figure out how to move around. The easiest way to do that is just kind of point and click in a direction, and you're going to fly there. You can even use both hands or use a trigger to sort of move faster. And you can also sit there and rotate in place. But my favorite way to move around is to just grab and scale the world with both hands so you can move, rotate, and scale all at the same time. And now that I've made myself kind of a giant sea monster here, I can see the scene from this perspective, and I can go over here and edit from a kind of God perspective. So I have my targets here, and I want to take one and duplicate it. And now I can reach out and grab it and move it around, and it's sort of attached to my hand. And if I touch it to other objects in the scene, I can see this little sphere here indicating that it's snapping to that place. And I can move it around without having to worry about intersecting the geometry and kind of putting it in an unnatural spot. So I'm going to make a couple more of these targets here and place them down in the scene. And now I'm going to show you the kind of the main event, which is this custom tool we've made for this game. So I'm going to open the menu and open the sequencer tool. And now I see this green line connecting two targets, and I can take one more and connect it to the next, and I can finish out the sequence. Oops. I can finish out the sequence by just doing like so. So now I'm going to hand it over to Dylan, who's going to show you some of the more advanced features of Editor VR.
Thanks very much, Sean. So let's take a look how we might go about placing a few more of these targets around our level using a feature from Editor VR called the Mini World. Just going to make our way over here, and we've got our targets here. So we got that one, and that one, and that one, and that one. And we're going to pop up a Mini World workspace. Put that right over here. Rotate our world over here. So cool feature about the Mini World is that we get to use position, rotation, and scale in order to focus in on a region of our scene that we'd like to interact with without the need to locomote over there or change our viewer scale in order to do so. So we've got this area on the building right here that we want to place these in, and we're going to grab these, and we're going to drag them into the Mini World. Now take a look in the distance as I do this. They enter the Mini World, and we're able to remotely place them in there using the view that we set up in the Mini World without the need to locomote again or change the viewer scale. So let's say that we want to keep our focus that we set up in that Mini World. We're going to use that later, but we want to place these somewhere else in our scene. So again, let's position, rotate, and scale ourselves over to the road in between the buildings here. And we'll go right about there. That looks about it. So we're going to grab, we can grab the building, or we can grab one of these, and again, you can see that we're moving it over there, remotely in the scene. It pops out, it's in the actual scene now, and then we drag it back in, and again, you can see this change reflected in the distance, but using the level of detail that we set up here according to the zoom level. Really cool, really handy feature. These will follow you regardless of the viewer scale, regardless of the rotation and position, so you can kind of think of them as bookmarks for areas that you'd like to interact with in Editor VR. So these are just a few of the tools that we're creating for VR creators that are using Editor VR and Unity 3D right now. Thank you very much. Oh, hey, what's going on, Sean? Good to see you. Thanks to the work from the team behind Scene Fusion, Editor VR also supports simultaneous multi-user VR scene editing and content creation. So Sean and I can work together building out a scene like this.
Yep, so Editor VR is available today. All you have to do is Google Unity Editor VR to get to our blog post that we put up back in December. You can download the experimental Unity build and the Unity package that enables you to use Editor VR. The code is open source and available on GitHub under the MIT X11 license. And we're really excited to see the tools and extensions that you guys come up with as a community. And as one last feature, yeah, never mind. Yeah. Anyway, thanks for coming out, and have a good show.
Thanks very much.
I want to take a quick opportunity to thank a few people. First off, I want to thank our friends and family who put up with us while we put this program together over the last year. I want to thank Jerome Solomon, the 2017 conference chair, for honoring me with leading this program. I want to thank my virtual jury who spent 2 weeks reviewing all submissions, sacrificed their own internet bandwidth, and whose knowledge and experience made our selection process much, much easier. Obviously, our on-site jury who will be selecting the best in show out of all of tonight's awesome content. Most importantly, I want to thank my team, some of which I have known since the days of being a student volunteer. Can we bring the house lights up, please? Can I have my conference team stand up, please? My conference committee, stand up. Thank you. Thank you, guys. I want to thank my outreach director, whom I've known and worked with since she was a student volunteer team leader, Gracie Arena Strittmatter. To our wonderful XSV who came through in a pinch whenever we needed them and survived a horrible Airbnb tragedy to volunteer for this conference, Jess Stack. To our amazing Smith Buckland admin who has helped to keep this program moving, Maggie Schutz. my producer and conference psychologist, and someone who is no stranger to SIGGRAPH, my right-hand man and the most dangerous Avenger, Josh Groh. Last but not least, I want to thank and introduce someone who has been an amazing help, an amazing shadow, and the Hall K God voice, your 2018 Real-Time Live Chair, Jesse Barker. Come on up, Jesse.
Thanks, Chris. I just wanted to come up real quick and say a couple of words. I'll echo what Chris said and say thanks to you all because it's really you that makes this kind of show as exciting as it is. Real-Time Live is, well, it's live, and it's just awesome. So I'm really looking forward to bringing this program to Vancouver next year. Vancouver is also awesome, and this show, most importantly, is not possible without the contributions and the submissions. So really look forward to this winter when we'll start opening for submissions, and tell all of your friends and your colleagues and anybody you think might be a clever real-time person to submit some stuff to the show next year. Thanks very much.
Ooh. Ah, thank you. We have the results right here. Okay, let's try and find out who it is. Let's do a little drum roll. There we go. There we are. Okay, and the winner is the human race. Come on, guys, storm the stage. This is your moment. Go on, take it. It's a little heavy.
Thank you, SIGGRAPH. And huge thank you to Epic Games, and also thank you to all the really hardworking artists and developers that helped make this happen. You guys are probably the smartest people I've ever worked with, and it's awesome to work with you guys. And also, it's really, I mean, you can tell by the turnout of this room that it's an exciting time to work in real time. So, hope you guys liked it.
Definitely want to thank the mill and everyone who worked on this project. You know, it's a long project. We learned a lot doing it, and you know, definitely want to thank everyone who took kind of big risks to take the project like this on, and want to thank everybody else who we were up here with. All this stuff is awesome. I love this. We all love this event every year. So looking forward to seeing what happens next. Thanks, everybody.
Thanks.
Wow, what an amazing experience. That has been great. That's pretty much the end of the show, guys. Thank you. I'm just going to be standing up here thanking everybody again, the entire attendee. I hope you have a great conference. Thank you. Good night.
then.